Hey guys, in this session we're going to be looking at simplifying fractions, particularly algebraic fractions. Okay, so let's get started. So to kind of start off this session, I'm going to look at some of the level 1 work we've done, or basically even just basic numeric fractions. So if you have a look at the first one here, this is my first question, and what I want to know is how to simplify it. Now, in this particular question, I can see that both 4's are common factors. So I can actually go both of the 4's cancel out, and I'm left over with x over y as my answer. Okay, that's the first example. The next example, we've got 3xy over 9yz. So what we do know is that y divided by y, well, both y's cancel out each other. And with 3 and 9, we know that 9 is 3 times 3. So, or in other words, to look at it is that 3 divided by 3 is 1, 9 divided by 3 is 3. So what we have in the numerator is 1x, so we're just going to leave that as 1x, divided by, in the denominator, we've got 3, and then we've got z. So that's what this function would look like when it's simplified. Okay, one more example, something like this. So I guess, as always, just work through one number at a time, or one term at a time. So looking at 15 and 25, we know that they're multiples of 5. So 15 can be divided by 5, which is 3. 25 can be divided by 5 also, which is 5. Now looking at the x cubed and x, we know that x cubed divided by x, what we do with the powers is we subtract the powers. But if you're really comfortable with it, then what you can just do is straight away just cancel out x and replace the 3 with a 2. And as for the y squared and y, cancel out the y and replace the y with a 1. And as for the two z's, they cancel out each other because z divided by z is just 1. So what we end up having is in the numerator we've got 3, x to the power of 2, y to the power of 1, but we're just going to leave it as it is. And that whole thing divided by what's in the denominator. We just have 5 in the denominator. And so therefore that's what the simplification of that function would look like, that expression would look like. Okay, so let's go into another question and be a little bit more challenging, I guess. So what about something like this? Now, if you've been following this video series, you know how to expand, or how to get rid of that squared, both of those squareds, and actually expand the brackets. So 3xy squared is going to look like this. So 3 squared is 9. And then you've got, so I'm doing this first, then you've got x squared, so 9x squared, then you've got y squared, which is y squared. Now this is being multiplied by 4. Obviously I've got x to the power of 4 squared, which would be x to the power of 8. Then I've got y squared. So this is what I have right now, and that whole thing is divided by x to the power of 3 and y to the power of 3. Now from here you can do this in two different ways. You can actually simplify the numerator and then work with the denominator, or you can directly work with the numerator and denominator as well. I'm going to show you guys both ways. So the first method, I'm going to simplify the numerator, and that's going to be in this side here. So we've got 9 times 4. 9 times 4 is 36. Then we have x squared times x to the power of 8, which would be x to the power of 10. And then we've got y squared times y squared, which would be y to the power of 4. Now all of this is being divided by x to the power of 3, y cubed. Now because there's no numbers, we can't really do anything with the 36. We're just going to leave it as it is. X to the power of 10 divided by x to the power of 3, well, that cancels out, and we're left over with 7x's, x to the power of 7 in the numerator. And as for the y cubed gets cancelled out, and we're left with y to the power of 1 in the numerator. So what we end up getting is 36 x to the power of 7, y by itself. Now, I was talking to you about doing this the other method, which is directly starting to work with the numerator and the denominator. So I'm just going to write the equation down first. So we've got 9x squared times y squared times 4x to the power of 8, y squared, and that whole thing divided by x to the power of 3 and y to the power of 3. So what I'm going to do is I'm going to get rid of x to the power of 3 with this one here, because that 8 will now change into a 5. Okay. As for the y cubed, I am going to get rid of this y squared, which means I've got y to the power of 1 left over. Then I can get rid of y to the power of 1 with this y here, which will convert to a 1 here. So if you look at what's left over, we've got 9x squared, y to the power of 1, 4, and x to the power of 5. And there's nothing in the denominator. So if you look at it, 9 times 4, so I'm basically doing this, 9 times 4, which is going to be 36. And then you've got x to the power of 2 times x to the power of 5, which is going to be this. Sorry, x to the power of 7, because x squared times x to the power of 5 is x to the power of 7. And then finally, I've got, what have I got left over? Oh, I've got y to the power of 1 just by itself. And as you can see, both of these answers are the same answers. Okay, let's have a look at another type of question, which is looking at fractions, and they're equivalent fractions almost, but the opposite way. So what I mean by is like this. If you have 3 over 6, we know that what we're doing to the denominator is we're multiplying the denominator by 3 to get to 18. That means you got to multiply the numerator as well. And so in this case, 3 over 6 is going to be 9 over 18. Another example. If we got 2a over 5, and that equals 15. Well, let's look at the denominator. The denominator is getting multiplied by 3, which means the numerator has also got to be multiplied by 3. So in this case, I'm going to get 6a. Okay, hopefully you guys are getting the message. One more example. Now, in this particular case, if you look at the denominator, I've actually got 5y. And my question is, what am I multiplying 5y to get to 5y squared? So from here, I can see that 5y times y would equal 5y squared. That means in the denominator, I'm multiplying by y, which means the numerator, I've also got to multiply by y. And when I do that, 4x times y, I actually get 4xy. Okay? Now, guys, this concept is really important to understand, because later on when we're dealing with algebraic fractions, when you're doing sum and what am I talking about? We're talking about sums and differences. It becomes extremely handy. So what our final answer for this particular case is that we've actually got 4xy over 5y squared. So it's kind of like the opposite of simplifying. Okay, let's have a look at a big question so it kind of starts making sense. So something like this. All right, so let's have a look at what's happening in the denominator. So you got to work through each of the components first. So first I'm going to basically do this. I'm going to write down 5cd, because that's the denominator, multiplied by something, and that equals to 20c2d3. Okay, so it's kind of, you just look at the numbers and the letters and see what's missing. So here I've got 5 and 20, which means I've got to do 5 times 4 to get to 20. So I'm going to write this as 4. Next, if I have c, I'm just going to use a different color, guys. Give me a second. So if I have c here and I've got c squared here, then c times what equals c squared? So I know that that's got to be c, because c times c is c squared. Next thing I have is I've got d here and then d cubed. So what am I multiplying by d to get to d cubed? Well, that's going to be d squared. So that's what I'm multiplying the numerator and the denominator by. Now, if you don't know how to do this, what you could also do is you could rearrange this. So you could actually just go 20 c squared d cubed, which is the denominator here, divided by this denominator, which is 5cd. And what you should see is that when we cancel out 20 and 5, so 20 is divided by 5 is 4. 5 disappears because 5 divided by 5 is 1. And then if you look at c squared divided by c, that's going to be c to the power of 1. And then if you look at d squared, d cubed divided by d, that's going to become d squared. And if you look at what's actually left over, you've got 4c d squared. And that, ladies and gentlemen, is what we actually ended up getting here. And this is exactly what we're going to multiply both the numerator by and the denominator by. because when we do that, the denominator is now equals to 20c squared d cubed. As for the numerator, we're going to get 4 times 3, which is 12. But then after that, you really don't have anything else. So it's just going to be cd squared p to the power of 4 q squared. Okay, let's have a look at one more example, but this time I'm going to do it fairly fast, guys, but feel free to actually give it a go by yourself. And that's this one here. So looking at the numerator, I can see that I'm going to, like I said, I'm going to do it a little bit faster, show you guys how to do this. So to get to 3 to 12, I'm multiplying by 4. To get to P4 to P7, I'm multiplying by P cubed. To get from Q squared to Q5, I'm multiplying by Q to the power of 3, which means I've also got to do the same thing with the denominator, 4P cubed, Q3. And when I do that, as you can see, 5 times 4 would be 20. As for the CD and P cubed, Q cubed, I can't really do anything. So that's just going to be left over as CD, P cubed, and Q cubed. So that's basically it, guys. I'm sorry about the long video. I try to make it really short, but I guess just got carried away with a couple of these problems. We'll try and make the next few ones a little bit shorter. So thank you for watching. Don't forget to like, share, and subscribe. And if you have any questions or comments, pop it in the comment section below. And thank you for watching.